One of the big things we want to try to do with a double integral is convert it into an iterated integral, because evaluating a double integral on its own can be really difficult, and there are a lot of challenges there, but iterated integrals are a lot easier to wrap our heads around. So one thing we know is if we have some continuous function and we have some sort of closed and bounded region, then we can take a double integral in terms of these differential areas, and we can convert it to an iterated integral where x goes from a to b, y goes from some function of two, it's bounded between two functions of x, and then we can integrate the function directly. So this is very similar to what we did in previous sections, where we were taking the area difference between functions, but now we're kind of using it to find volume. So let's do it with a practical example. We want to find the volume of the region bounded by the xy plane, and the surface z equals 2 minus x minus 2y, and we want only care about the cases where x is greater than 0 and y is greater than 0. So realistically, we care about the plane up here, and we only care about these regions. So we kind of have it bounded by the xz plane, the yz plane, and the xy plane. So to do this, there's really two steps that allow us to use this. By the way, is a result of what's called Fubini's theorem. Technically, in this case, we're doing something that's Tonelli's theorem, but you can look that up on your own time. So the first thing we want to do is find the bounds. So let's see, that's purple. So let's not use purple. So if we look at it this way, we need to find what x goes from. Well, x looks like from 0 to 2. But what do we do about y? Well, if you look at y, you see that we have a line here. So we can get the value of y based upon what the value of x is. So if this is a line, you could think of that as being the point 0, 1 and the point 2, 0. So that's going to get us, that looks like that has a y-intercept of 1, and it looks like it has a slope of -1/2, right? Because if you go over 2, you go down 1. So -1/2 x plus 1. But this is the key where it gets a little tricky. You might want to, so y goes from 0 to that. From 0 to that. What does that mean? Well, what that means is we're trying to look for this whole volume. So when x is 0, y has all of the values up to there. Y has all of the values, all the way to the point where, so in this particular case, if x is 2, y just goes from 0 to 0, which is what you expect here. But in this particular case, when x is 0, y goes from 0 all the way to 1. So you need to think about how y is changing over that whole strip. So that tells us, those tell us our bounds. And then, of course, the function that we're integrating is already given, because we're just getting the x and y bounds, and that z function is giving us the height for the volume that we're integrating. So let's see. Sorry, I had to check my notes here. So z's there. So the first thing we do is fill out the bounds. 2 is evaluate. So to do this, we say, all right, x goes from 0 to 2, y goes from 0 to negative 1 half x plus 1 of this function. Notice we do dy dx because our x bound or our y bounds are there. So integrating this, we go from 0 to 2y minus xy. So let's do this. Let's call it 2 minus xy minus y squared from 0 to negative 1 half x plus 1 dx. Again, that's 0 to 2. So another thing you might do is write this as 2 minus x over 2. The reason why is because now when I plug this in, I get 2 minus x over 2 minus 2 minus x, or sorry, 2 minus x squared over 2 minus 2 minus x squared over 4, right? Because to square this, I get 2 minus x squared, 4. And then, of course, when y is 0, it's just 0 dx. So that gets me 1 half 2 minus x squared dx. And we can multiply this out, but honestly, I would just use substitution. I would say u is equal to 2 minus x, du equals dx, or negative dx. So that gets me negative. When x is 0, u is 2. When x is 2, u is 0. 1 half u squared du. Remember, we can take the negative and flip. All right, we flip the limits of integration and change the sign. That's 1 half u squared du. So that's 1/6 u cubed from 0 to 2, which is 8/6, which is 4/3. Which for some reason is different than what I have in my notes. So if you find an error, let me know. But otherwise, this is the basic steps here.